This is the third lecture that has to deal with the photon theory, or the idea that light comes in photons instead of waves, right? The first two are the photoelectric effect. One was more the lecture, the other one was problems, and then this one is dealing with a different situation. This is dealing with when the photon does not have enough energy to overcome the work function, right? So the electron doesn't break free from the atom, right? But if it gained energy, it still has more energy than it did before. It just wasn't enough to break it free. So what happens in those cases? So it's a fairly straightforward set of rules for this. First of all, an electron can still gain energy. You can gain energy from the photon because that's conservation of energy, but it only gains energy in set amounts, and that set amounts has to do with the atom or the element that we're talking about. So it could only get energy in set amounts, and then if it tried to gain more energy, that it would still go to that set amount and immediately get rid of the excess energy that it can't use, right? So it would produce a second photon that would be discharged, that would get rid of all the energy that it couldn't use. So let's look at this. This is the very common model that describes what we're talking about. And the model that I made is simply one that's going to be easy to work with. It's not an actual element. It's not an actual type of atom. A lot of the atoms are going to be more complex than this. They're going to have many, many more horizontal lines, many more energy levels. And these numbers don't really have any big significance either. These are simply numbers that I picked. But I think it's a better working model than to try and look at the real thing. That's going to have a lot more levels going on. So first of all, this bottom line, which is really the ground state, is the atom when it's at its lowest energy amount, right? So we're going to label that. Here we go. Ground state. So ground state is the electron, again, with the lowest energy that it would normally have. As we give it energy, as photons strike, or as a photon strikes and it gives us energy, it would move from its ground state up to these other states, state 1, state 2, state 3, and this is kind of that tipping point. The other thing we know is that the 13.6 is the work function, and just by looking at it, we know that's the work function, because if I gave it 13.7, it would leave this model, right, and it would leave. So it would be an electron that breaks free. So just by looking at this model, we know the work function for this material, 13.6 electron volts. And they're written this way because this is the amount of energy it takes to keep moving it up to the point where it just breaks free. And the 0 electron volts is when the electron would just break free with no kinetic energy. So we can move up from this to other ones. Well, if we look at it, then we can move from here. Come on. We can move from here to here, and it would take 13.6 minus 9.8. It would take a photon of 3.8 electron volts to cause it to do that. 3.8 electron volts. So if a photon came in with 3.8 electron volts and struck this electron can go to this level. 3.8 is not enough to break it free. It takes 13.6, but it would bring it to a higher energy state, this being the first higher energy state. Now let's say that that electron volt, that photon, was 4 electron volts, which is more than enough energy to bring it up here. Well, it would use 3.8 to move up here, and then it would discharge a second photon that's 0.2 electron volts, right? That's what happens. So it would immediately get rid of all the excess that it didn't need to bring it to this level. It wouldn't bring it up to 7.2 because that wasn't enough energy, but it would bring it up to the 9.8, right? Another one, just to say it. If I went from, well, let's say that this electron was now here, and another electron struck it, and that electron struck it, and it brought it up to this level. Well, 9.8 minus 2.8, this would take a photon of 7 electron volts. And again, if it was here at state 1 and moved up to state 3, and it received an 8 electron volt photon Well, it would go to this point and it would immediately discharge the excess, which would be 1 electron volt. So this is how it goes. It moves up at energy levels. But the other thing is too, is it doesn't stay at those energy levels. Now, if we have an electron that's here at this 1, 2, 3, this third state, it doesn't stay there forever, because in the end, it's going to want to drop back down to here, right? So it's going to move up to very specific levels when it gets excited, but when it's excited, it's going to move back down. Now, this has some choices. Let's say that we had an electron at this energy state. It could move all the way back down to ground state, getting rid of 1 photon being discharged, 13.6 minus 2.8, and that 1 photon would be 10.8. That didn't look right. Yeah, 10.8. That looks okay. Okay. That's a very big marker I picked. It could discharge 1 photon, that's 10.8. I'm going to use something a little skinnier on the other ones. Or it can do this. It can drop off 1 to get to here, and then drop off another to get to there, and then it can drop off another to get to there. So this is another possibility. There's more than 2. But when it goes from 2.8 to 7.2, right, it must have lost energy. So it must have lost 4.4 electron volts here. And then as it goes from negative 7.2 to negative 9.8, it would get rid of another one, which is 2.6 electron volts. And then it goes from 9.8 to 13.6. It would get another one, which would be 3.8 electron volts. That was an awful E. Let's pretend that was a good E. 3.8 electron volts. So these are 2 possibilities. If we could excite an electron to get to this energy level, it could give off 1 big photon, which was 10.8 electron volts. It could do this, where it drops off 3 different ones, and it could do more things. So let's kind of change it here. I'm not going to put all the numbers in, but what else is possible? Well, it could go down to here and then go to there. So this is a possibility where it still gives off a 3.8, but then it also gives off a 7 electron volt, right? Also, if it's up here, what else could it do? It can go to here. Let me change my color again. Orange could go to here, and then from there it can go all the way down to the bottom. So it could drop off a 4.4, and then it could drop off these, just 1 photon equal to the 2 of these. So it would be what? 6.4 electron volts, right? So it has choices when it de-excites, but there's not a ton of choices, and it's still, you see, it's kind of follow into the same patterns. So as an electron gets excited, it gets excited to very specific levels, and then when it de-excites again down through those levels, right? And it could jump levels, but in the end, there's still only so many combinations that it can go. And the second one is usually where we see the more practical application, right? Fluorescent lights, like the light tubes in the classroom, right? Those electrons are getting excited, but they're not getting excited through bombarding it with photons. They're getting excited by bombarding it with electricity, right? So it's getting excited through, it's gaining electrical energy, which is exciting these electrons. These electrons get to an excited state, and as they de-excite, they give off photons. And some of those photons are in the visible spectrum, which therefore makes light. So that's one example of what we're talking about. And the second example, which is really kind of the same example, when we looked at diffraction, when we looked at colors, I had gases and we put them in the, we had different tubes of gases and we excited those gases and they gave off light, right? And they gave off light in very specific colors. Well, that's the same thing we're talking about. Through electricity, these electrons were excited. As they drop down in very specific ways and give off certain photons. And some of those photons are in the visible spectrum, so we saw those colors. We didn't see every color because some of those photons didn't match up, or some of those colors didn't have an energy level that matched up with these levels that it can go down. So that's the start of the last part, right? And this is actually it. If that makes sense, now we're just going to put numbers to it. But this is now talking about what happens when electrons get excited, but they don't get enough energy to break free, right? Well, they reach specific levels and then they drop down through those same specific levels.